Hi, we have AP Physics 1 past paper 2024. We are discussing free response question section. In this section, question number 1 carry the 7 points. The block of mass m is released from the rest at the point A, a height 6r above the horizontal as shown in a fig. After being released, the block slide down a track as shown. When released at the point A, the block doesn't lose the contact with the track at any point. The point B and C are located at the highest point of their respective circular loops. As you can see, the B and the C as the topmost in the loop. All the forces, frictional forces are negligible. Diagram A show the energy bar chart that represent the gravitational potential energy of the block or system and the kinetic energy of the block at point A. When a block is released from the rest at the height h6r, draw the shaded region in a diagram B that represent the gravitational potential energy and the kinetic energy of the block or system when block is located at point B and the height is 2r above the gravitation above the horizontal. Shaded region should start at the dash line that represents zero energy. They represent any energy that is equal to the zero with the distinct line on zero energy line. Relative height of the each shaded region would reflect the magnitude of respective energy consistent with the scale as shown in a diagram A. Okay, now the question in simple, there is a represent the potential energy that is the six scale is there. Now there is initially the body is at the rest, so kinetic energy is zero level. Now it is asking in diagram B when the point is at B, that is 2r height. This is representing the 2r. So as it is state, the what is 2r height above the horizontal. Now we have to draw the diagram B for the P point. So there is no friction, mechanical energy is conserved, total energy at A should be equal to total energy at point B. In initial there is kinetic plus potential, body is at rest, so kinetic energy is 0, potential energy is mg6r. Kinetic energy represented by Kb. Now the potential energy is mg2r because 2r is given. So we can calculate the kinetic energy, that is 4 mgr. So I have reduced the potential energy from 6 mgr to, you can say, 2 mgr as we come to know, and the potential energy is equal to 4 mgr. So that's the reason, that's the 4 scale we can represent 4 mgr kinetic energy according to the scale. Now, with the conservation of energy drives the expression for the speed of block B at express your answer in term of R physical constant as appropriate, being your derivation writing the fundamental principle or equation from the reference book. So there is no friction, as we said earlier, mechanical energy is conserved, total energy at A should be equal to total energy at B. So we place the kinetic energy formula 1 by 2 mvb square. So we can cancel the m from both sides. We calculate the 6 mgr minus 2 mgr, that is equal to 4 gr. You 2 can move from here. So that is 8 mgr. So we have to calculate the value of only velocity. So velocity is equal to square root 8 gr. So that's the velocity at the point B. That's the question in ask. Now on the next part of the question, on the following dot represent the block, draw the label forces, not the component that exerted on a block as the instant block slide through point C. Each force must represented by the distinct arrow starting and the pointing away on the dot. If you see the point C is the topmost level of the loop in this loop. So as we come to know that the gravitational force, weight is acting always downward toward the center of the earth. So that is the gravitational force represented by Fg. Now the normal force exerted by the track on a block, it is perpendicular to the track because it is at the highest point on the, so no, perpendicular should be directed toward this direction. So we can say at the top of the loop track is above the block, so normal force is directed downward toward the center of loop to provide the centripetal force. So that's the reason both forces are directed downward. So that's the normal force and the gravitational force both combined provided the centripetal force to move the block in a circular loop. Now, the student claim 4r is the minimum height at the point A such that the block can slide through the point C without losing the contact with the track. After block is released from rest, briefly explain why this claim is incorrect. Now, at point C, we have to discuss net force toward the center provided the centripetal force. If the block just barely maintain the contact, normal force becomes zero and the gravity alone centripetal force. Now, mg is equal to mc square over r, m can be cancelled, so vc square should be equal to gr. Let the minimum height, starting minimum height is h, energy at the start is mgh, energy at the top of point C is mg2r plus 1 by 2 mc square. Because there is both potential energy and the kinetic energy is present, we can place the vc value of vc here, that is gr. So the equation become mg2r plus 1 by 2 into gr. So using the conservation of energy, before starting energy should be equal to at point C energy because there is no friction. So mgh is equal to mg2r plus 1 by 2 mgr. M and g can both be cancelled from equation. So h is equal to 2r plus 1 by 2r, that is equal to 2.5 r. Now the minimum release height required to block just reach the point C without losing the contact is 2.5 r, and his claim 4r is the minimum height he claimed. So that's the incorrect because 4r is already higher than necessary. A lower starting point will still also work with it. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.